The intriguing dance of scientific inquiry, theory versus law versus hypothesis. Have you ever wondered how scientists make sense of the ever-expanding universe of knowledge? It all starts with a curious mind, a keen eye for observation, and a structured approach to investigation. This is where the power trio of scientific theory, law, and hypothesis comes into play. Today, we'll embark on a journey to understand their distinct roles in the scientific quest for truth. The spark of inquiry, the hypothesis. Imagine you're gazing at a lush garden, captivated by the vibrant colors of blooming flowers. You notice that the flowers closest to the window seem to be thriving more than those tucked away in the shade. A question pops into your mind: does sunlight affect flower growth? This is where the hypothesis takes center stage. A hypothesis is an educated guess, a tentative explanation for an observed phenomenon. It's a starting point, a springboard for further investigation. In our flower example, your hypothesis might be, flowers that receive more sunlight will grow taller than those that receive less sunlight. Building the case, testing the hypothesis. A well-crafted hypothesis is like a detective's hunch, it needs to be tested. This is where the scientific method flexes its muscles. You might design an experiment, divide the flowers into two groups, one placed in direct sunlight and the other in partial shade. After a set period, observe and measure the growth of each group. Did your hypothesis hold true? The evolving tapestry of knowledge, the scientific theory. Now, let's say numerous experiments, conducted by different scientists under various conditions, consistently support your initial hypothesis. This accumulated evidence paves the way for the development of a scientific theory. A scientific theory is a well-substantiated explanation of some aspect of the natural world, based on a body of facts that have been repeatedly confirmed through observation and experimentation. It's not a static proclamation but rather an evolving framework that incorporates new discoveries and refines our understanding. For instance, the theory of evolution by natural selection, proposed by Charles Darwin and Alfred Russel Wallace, has been extensively tested and refined over centuries. It provides a comprehensive explanation for the diversity of life on Earth. Understanding patterns, the scientific law. Scientific laws, on the other hand, describe consistent relationships between phenomena. They are concise statements, often expressed mathematically, that summarize these patterns. Unlike theories, which delve into why things happen, laws focus on how things happen. For example, the law of universal gravitation, formulated by Isaac Newton, describes the attractive force exerted between objects with mass. It doesn't explain the nature of gravity itself, but it allows us to predict the motion of planets, satellites, and other celestial bodies with remarkable accuracy. Mind-blowing facts, the twist in the tale. Here are 3 intriguing revelations about scientific theory, law, and hypothesis. 1. Theories don't graduate into laws. It's a common misconception that theories become laws with more evidence. Theories explain why something happens, while laws describe how it happens. They serve different purposes, and neither is superior to the other. 2. Theories can be powerful predictors, despite their focus on explanation. Some well-established theories, like the theory of relativity, have made incredibly accurate predictions that were later confirmed through experimentation. 3. Laws can change too. While generally considered very stable, scientific laws can be revised in the face of new evidence. For example, Newton's law of gravity was superseded by Einstein's theory of general relativity, which provided a more comprehensive explanation of gravity under extreme conditions. The enduring quest, a journey of discovery. The interplay between theory, law, and hypothesis is the cornerstone of scientific progress. It's a continuous dance of observation, questioning, experimentation, and refinement. As we delve deeper into the mysteries of the universe, these concepts remain invaluable tools, guiding our exploration and shaping our understanding of the world around us. So, the next time you observe something intriguing, remember the power of scientific inquiry. A hypothesis might just spark a revolutionary discovery.